Hi, this is Mr. Estrada. In this video, you're going to learn how to determine the common ratio in a geometric sequence, determine a specified term of a geometric sequence, and how to find the sum of specified terms in a geometric sequence. Okay, so first, what is a geometric sequence? A geometric sequence is a sequence of values that follows a pattern of multiplying a fixed amount that's not zero times each term to arrive at the following term. The number multiplied each time is constant, always the same. So here's an example of a geometric sequence. Because you have values that follow a pattern of multiplying a fixed amount. So 3 times some number gives me 9, and then 9 times that same number gives me 27. That's why this is a geometric sequence. It follows a pattern of multiplying by a fixed amount. This is also a geometric sequence because it follows a pattern of multiplying by a fixed amount. Okay, so what is that fixed amount we're multiplying by? In this case, we're multiplying by 3. Multiplying by 3. 3 times 3 is 9. 9 times 3 is 27, and so on and so forth. In this case, the fixed amount you're multiplying by is a half. So you can multiply by a fraction as well. 80 times a half is 40. 40 times a half is 20. 20 times a half is 10, and so on and so forth. That fixed amount you're multiplying by has a special name. It's called the common ratio. And it's denoted R. So the common ratio here is 3, or we can denote it R equals 3. Here we can say R equals a half. Here, what are we multiplying by to get to the next term? Well, 1 times 3/4 gives me 3/4. 3/4 times 3/4 gives me 9/16. Here, R, the common ratio, equals 3/4. How do you know whether or not you're dealing with an arithmetic or a geometric sequence? Well, here's how you know. In an arithmetic sequence, you are adding. See here? You're adding by 3. So 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13, so on and so forth. You're adding by a fixed amount. Here you're adding -5. 15 plus -5 is 10. 10 plus -5 is 5. 5 plus -5 is 0, so on and so forth. You're adding by a fixed amount. In a geometric sequence, you're not adding, you are multiplying. So one question you want to ask yourself, if you want to know whether or not you're dealing with an arithmetic or a geometric sequence, is this: are you adding or are you multiplying to get to the next term? And if you're adding, it's arithmetic, and if you are multiplying, it's geometric. By the way, before I go on, you do realize that the term geometric doesn't have anything to do with shapes. When we refer to geometric sequences, we're talking about sequences. So don't get thrown off by this term, by the way it sounds, because it sounds like geometry, so you probably think, okay, this has something to do with geometry. Formulas used with geometric sequences and geometric series. So you might want to pause the video right now to write these down. Okay, find the common ratio for the sequence. So the common ratio is the fixed amount you multiply by to get to the next term. So if I want to know what 6 has to get multiplied by to get to -3, I can just say, what's -3 divided by 6? And that's going to give me the common ratio, which is -1/2. So the common ratio is -1/2. So, if you want to get the common ratio, just divide the second term by the first term. And that's how you get the common ratio. So 6 times -1/2 is -3. -3 times -1/2 is 3/2. 3/2 times -1/2 is -3/4. Find the 7th term of the sequence. So if you want to find the 7th term, we're going to use the formula that you see here. So we are looking for A7, that's the 7th term. A1 represents the first term, that's 2. So it's going to be 2 times R, that's the common ratio. So what's the common ratio? Well, that's going to be 6 divided by 2, that's 3. So times 3 raised to the n minus 1. Well, you're looking for the 7th term, so n is going to be 7, so it's going to be 7 minus 1. And you get 2 times 3 to the 6th power. Well, what's 3 to the 6th power? Let's take out our calculator. 3 to the 6th power is 729. So it's going to be 2 times 729. 2 times 729 is 1,458. So the 7th term, denoted A7, is 1,458. Okay? Just for the sake of learning, why don't we find these the rest of the terms up to the 7th using the common ratio? So 54 times 3 is 162. 162 times 3 is 486, and 486 times 3 is 1458, which is what we had for the 7th term. 1, 2, 3, 4, 5, 6, 7. 7th term. So even though this was not tedious to do here, because you just had to multiply 3 times to get to the 7th because you were already given 4 terms, it can become tedious if they ask, let's say, for the 100th term and you only have the first 4 terms. So that's why this formula is useful. Find the sum of the first 8 terms of the sequence. So our formula here is used to find the sum of a geometric sequence, and A1 represents the first term, R represents the common ratio, and N represents the last term, which in this case is going to be 8 because you're looking for the sum of the first 8 terms. So we are going to substitute. So we are going to write S. So we want the sum of the first 8 terms. 8. We write that. That's 8 equals A1, so that's the first term, that's negative 5, times 1 minus R to the n, so that's the common ratio. So I have to figure out what R is. So R is going to be 15 divided by negative 5, which is negative 3. So it's going to be 1 minus negative 3 raised to the 8th power, because I'm looking for the sum of the first 8 terms, over 1 minus negative 3. So it's going to be negative 5 times 1 minus negative 3 to the 8th. So let's see what negative 3 to the 8th is. So negative 3 to the 8th. Make sure that that negative 3 is in parentheses the way I put it here. And you get 6,561. So it's going to be 1 minus 6561 over 1 minus negative 3, that's 4. Keep, change, 1 plus 4. So that's going to be negative 5 times, so that's 1 minus 6561 negative 6560 over 4. So negative 560 times negative 5, that's 32,800 divided by 4. The answer is 8,200. And that's the sum of the first 8 terms. Okay, I hope this video was helpful. I look forward to working more on this topic with you in class. Take care.